There we go. So,
right, can you hear me, Mother?
We've got you. So here we go. So hello, everybody. Welcome to the Denbighdale Amateur Radio Society Club meeting. We are very, very spoilt to have quite so many people with us now, and no doubt watching this on YouTube later. So I'm very pleased to introduce to you Richard M0SNR, who's going to share with us some of his amateur radio journey working the QO-100 satellite, which is something I don't know anything about, so we're paying very careful attention. All yours.
Right, okay, can you see my screen at the moment, Ian?
We can see your screen, it looks fantastic.
Okay, that's actually the receive antenna from the, it's based in Chernobyl, and that was used for the woodpecker. So you've got a high frequency array here and a low frequency array here. So that's been my backdrop for many, many, many years. So have you got that?
Yeah, we got that.
Okay. So I'm not going to say, I'll switch my video off. Okay. No, I'll leave it. I'll leave it. So I'm not going to say that my way of doing things is correct. As everybody knows, there's more than one way to skin a cat. There were some specifics that I wanted to try to do, which I'll try and cover. Please, guys, I mean, Ian, how do you actually work the Q&A? Is it text-based or how do you do it? Ian, you're muted. Sorry, mate.
Can you hear me now, Mother?
Yeah, gotcha.
Yeah, normally the presenter runs it how they want, with normally the presentation with a Q&A at the end. But if you're confident and would like, if you want questions on the way, we're more than happy to do that too.
All right. Well, questions on the way. I think the problem is if everybody, you can forget a question during the presentation. So if anybody wants to butt in and ask a question and then mute afterwards, that's fine with me. I really don't mind. As I say, I'm new to Zoom. This is the first time I've used Zoom in a production environment. So anyway, this is my thoughts. As I say, your mileage may vary. The way that you do something might be completely different to mine. And as I say, I'm not saying that my way is perfect, correct, or anything like that. All I wanted to try to do is just give a bit of an overview as to what's what. So a little bit about me. I've been interested in communications and amateur radio since I was probably about 6. My late uncle got me interested in it. So I passed the RE back in 1983, sat on my pass certificate. I found out about beer, about women, and the finer things in life. And in 2004, there was a program on Radio 4 about the work that amateurs did when the Twin Towers came down. And sadly, some of our brethren were lost. And that really got me interested in amateur radio. So I applied for the call sign M0RJY, which wasn't available at the time, which are my initials. And there was a car outside M0, which ended in SNR. And I just saw the car. I thought, okay, what about M0SNR? And I said, yeah, that's available. So that was me on air. I've worked in the electronics industry since about 1989. I worked for Microchip. I'm pointing to the wrong, that Microchip, and I guess people know who we are. So we make PIC microcontrollers, all sorts of stuff. The part of the business that I work for is what's called the UNG group. So it's USB and networking, and I've been with the company for, it'll be 7 years in September. Absolutely love it. Fantastic company to work with. Brilliant. So I'm based in the West Midlands, India Oscar 92 Charlie Mike. If you drive on the M6 heading northbound and you pass junction 5 and you look up, you can see some antennas, and that's my house. So if you're ever coming by, give me a shout and you'd be more than welcome to pop in and have a cup of tea. I'm the repeater keeper and owner of the GB7EZ DMR Phoenix repeater, which is in my rack in my office, which is probably making a little bit of noise at the moment. So basically, when we had lockdown, I decided to chuck myself into a number of different projects. The repeater was one of them, and getting the satellite system up and running was another one. My main interest is radio comms, but reliable radio comms. I'm not into chasing DX, NVIS comms, digital modes, satellite comms, repeaters, that kind of stuff. That's really interesting to me. Very much into audio. I'm a bit of an audiophile. Time's always been something that's really quite interesting to me, and I've been playing about with a lot of time-sensitive networking for Ethernet. And one of my projects is to try to discipline a 1920s pendulum clock, which my grandmother had, to my grandmaster clock, to see if I can. There's something called synchronicity. And if you've got two oscillators that are slightly off frequency, you can pull one with another one, which has got a slightly more higher level of impingement. Fascinating, absolutely fascinating subject, but that's for another day. So QO-100, it was launched in November 2018 by the Qatari government, Qatari consortium of companies. The German AMSAT organization worked very closely with the owners of the satellite, and they managed to get two transponders on board, one for video and one for audio. Is there a question?
There was just a mic getting rubbed, not a problem. It's muted now.
Okay, so basically there are two transponders on board. I've done nothing with the wideband DATV stuff. I'm just purely working on the narrowband transponder. So narrowband is vertical, wideband is horizontal, and both are right-hand circular polarization. So instead of using either vertical or horizontal for the uplink, you actually use circular. Uplink is 2.4 gigahertz, and then downlink is on 10 gigahertz. One of the nice things about 10 gigs is that you can use off-the-shelf TVRO LNBs. So the coverage of the satellite itself is from Brazil in the west, right the way through to Thailand in the east. So it's got a massive footprint. I think it covers about a third of the planet. And it also covers both of the poles as well. So you get quite a lot of traffic from stations that are in either the north or the south pole. And they can be quite interesting. They get an absolute massive amount of pileups when they're on air. Really interesting to hear. So you need to put a bias supply on to. So typically, most of us will be using an amateur receiver to receive the signals from the satellite. So what you need to do is to put a 12 volts for vertical polarization onto the feeder to the LNB, and then that will basically allow you to start to receive satellite. Basically, you can start to sort of listen to the thing. Most LNBs will give you a 739 megahertz output, but there are some others from, for example, Kuna, which will give you 70 centimeters direct from the LNB. So it really depends on what you want to do. In the UK, I would probably recommend that you go for a 1 meter dish or something a little bit bigger if you can. I have been doing some experiments with a 60 centimeter dish, and it's probably a little bit too small from where I am. So this is the coverage map. As I say, you can get right the way across from Rio de Janeiro, right the way across to sort of Thailand, China, right, Europe's no problem at all. And there is quite a lot of traffic. The satellite itself supports, through the narrowband transponder, supports CW, well, you get CW traffic, Digimode traffic, and SSB traffic. The thing is, it's a linear transponder, so no matter what is put in on the uplink, it'll come out on the downlink as well. So this is the band plan. So originally the band plan was a little bit shorter. I think it was 500 I think it was basically a lot shorter than this. I think it was 250 kilohertz. But fairly recently it was expanded to 500 kilohertz. So you've got CW, narrowband stuff, digital modes, SSB only, and then you've got mixed modes and other bits and pieces. There is also an emergency frequency that is used as well for obvious reasons. And then there is a contest area, and then you've got another beacon. So one thing that I would say is these beacons, particularly the CW beacon at the bottom end of the band, they are absolutely godsends. They're so useful to be able to pick up the satellite, to get your dish aligned on, and then once you've got the dish aligned, then you kind of know that you've got access to you can hear the satellite. So as I said before, you've got uplink on 2.4 gigs and downlink on 10.5 gigahertz. What else can I say? So that's basically it. But the nice thing, as I say, it's a linear transponder. So whatever goes up comes down. So because you're running at 10 gigahertz, it's quite a good idea to try to use this GPS discipline. So basically what you're doing is you have an accurate reference frequency that you use to synchronize the various different parts of the transmit and receive chains. So for example, the way that I've got my systems, I'll talk about that on the next stage, but one of the big problems is that a lot of the commercial low noise blocks that we use for receiving are basically standard things that you might use for example, Astra or Sky or whatever. And because you're receiving a wideband signal, the requirements to have accurate timing and accurate frequency control within the LNB are very much relaxed. So you don't really need a particularly good LNB for TVRO applications. But obviously, if you're talking about signals that are 3 kilohertz wide, then the requirement is a little bit more stringent. So a lot of people tend to use GPS or GNSS. GPS is one type of GNSS. GNSS is Global Navigational Satellite System. So you've got GPS, GLONASS, Beidou, Galileo, etc. So there are different GNSS systems that are available. And this was something that I added to the project towards the end. So this is my current setup at the moment. Let me just see if I can switch on annotation. So the dish itself has got an LNB at the front. So there's an LNB there. And then that then has a local oscillator of 9.75 megahertz. So the 10 gigahertz or 10.5 gigs that comes into the LNB is then mixed and then basically brings you down to 739 megs. As I mentioned earlier, LNBs need a 12 volt feed. So what you do is you impinge the 12 volts onto the coax, which then powers the LNB, and then you just use effectively a bias T to separate the RF plus DC to the RF only side. So you've effectively so the bias T puts the 12 volts onto the LNB and it brings out the 739 megahertz, which then goes into my SDR. And then from there, I've got GPS disciplining for the SDR. And then you've got both audio and frequency control between the SDR and the PC. And then from the PC, I've got CAT control to the 2-meter transmitter. Again, that's GPS disciplined to the transverter. And then the transverter transverts from 144 megahertz to the 2.4 gigs, which you then use for the uplink. So that's basically the system as it stands at the moment. So all of the parts of the system are GPS locked. But going for a decent bias T is something that's worthwhile doing. The one that I've got, I've actually blown a couple of them because the inductor tends to be it's a small surface mount device, and if you put any more than 100 milliamps through it, it just basically vaporizes. So the bias T that I've got, I effectively shorted it out, and I've just got bias directly to the LNB side and just a capacitor on the other side. So, and it kind of works. I've not had any major problems with doing it that way. So the software runs on the PC. It controls and sets the transmit frequency and the SDR receive frequency to tie up both the uplink and the downlink. And so that's basically where we are. So these are the component parts within the system that I have at the moment. The first LNB that I started off with is, hang on, let me just change this because you can't really see it very well. Draw clip line. Right, so the LNB that I started off with was from, it's a bullseye LNB, fairly cheap. I think I paid about 30 quid for it, but these things are really good because the accuracy is, they claim to be within 10 kilohertz across the temperature range that they're designed for. So you don't tend to get too much frequency drift from them. So you're typically within about 10 kilohertz. I would say they're probably a little bit more than that. So for receive, these are really good. You can start off with a really cheap £10 LNB just to get yourself to a point where you can receive a signal from the satellite. But if you're going to start doing anything as far as deploying a transmit receive chain, then excuse me, I would definitely go to start off with one of the bullseye LNBs. This is the bias T that I use. It was from Amazon. I think I paid about 20 quid for it. As I say, the inductive element is pretty useless, so I took that out and replaced it with a short effectively, and it seems to work. But you've got to be careful because there are different versions that cover different frequency bands. This one I think is good to, I think it's 5. I can't remember what frequency. I think it's 2 megahertz. Sorry, 2 gigahertz. Then on the uplink, this is the antenna that I use. These are absolutely brilliant. It was by a guy, DO8PAT, and he basically did the design for it. So it's a 3.5 turn helical. And the nice thing about this is that it mounts concentrically with the end of the LNB. So you can put the so basically you can mount this onto the end of the LNB, and it doesn't shade the LNB too much. For GPS disciplining, I use the Leo Bodner stuff. They're fairly cheap. You pay about 100 quid for one of these, and you can program the frequency that you need. The LNBs typically need 24 megahertz, and the rest of the chain either uses 24 or 10 megs. So for example, with the SDR plate, that's the RSP DX that I use for receive. That'll cover from, I think, about something silly like about 10 hertz right the way to 2 gigahertz. So that's what I use for my receive chain, and then that basically connects directly to the LNB. Where was I going from there? So once I've been playing about with this LNB, I decided I wanted to go for a decent GPS locked LNB, and the one that I went for is this one, and this is from a company called DX Patrol. So you've got 2 ports. You've got one which is for the actual 739 megs output, and then you've got another one which is for your GPS discipline, for your 24 megahertz reference clock. Then for uplink, I use the Kuna phase 4 up converter. And then just basically to make things a little bit easier, you've got, I use an ELAD TM2 controller, which basically gives you a nice user interface to the whole system. So you can tune up and down the band, you can set volume levels, you can play about with the filter settings, etc. from that. And then one thing that I do need to do at some stage in the future is I have got disciplining for the radio at the moment, but this is a board which could potentially give me better results as far as disciplining. And this goes back to what I was talking about earlier on regarding frequency locking. This uses synchronicity to effectively impinge directly onto the oscillator within the board. So it has a loose a tight coupling onto the tank circuit of the main phase lock loop, and it can basically pull the oscillator. So it gives you better accuracy. So the feeder, that basically what I wanted to do is I wanted to keep the up converter and everything in my shack. I didn't really want everything in a box at the bottom of the garden. It's about 25 meters away from the shack, so there is a real potential for a lot of loss at 2.4 gigs, because obviously I'm carrying 2.4 gigs from the shack down to the dish at the bottom of the garden. So I decided to use Heliacs for the main run, and then a couple of shorter runs of LMR600, which basically means that I can put a cable through the wall and I can actually bend it, because the problem with the AVA 5-50 is it's almost impossible to bend it. So the Heliacs itself, I reckon it's probably got a loss of about 1.5 dB across 23 meters. It is, as I say, quite big. It's about 1.2 inches in diameter, so you really can't bend it. So I went for Andrew CNT 600 coax, which is a lot easier to bend. And because I'm only using a fairly short amount of runs, the whole link loss isn't as bad as it could potentially have been. So I'm reasonably happy with the results that I've got on that one. So this is, oh crikey, I thought I got rid of all those. Right, okay. So hang on, let me tell you what. I'm sorry about the rings and the rest of it, but so this is the dish and the LNB. So as I say, the feed itself is concentric with the LNB itself, and I'm using the AVA 600 just to basically couple to the feed point itself. That's the feed itself. So as I say, it's been up now for about 18 months, and I've had no problems at all with water ingress. And then that's the coupling between the Heliacs and the 600. So it was fairly easy. I actually bought the cable from a company called the DX Shop in Wales, and they were absolutely brilliant. Really looked after me very, very nicely. They terminated the Heliacs, and the connectors for the CNT 600 were really easy to fit. Compression with a bit of soldering. And then behind it, you've got the actual LNB GPSO unit, which has got everything in the box. And then there's the cable. So you can see it is actually quite a bit of a monster to go down the garden. And there's no way on earth that you can bend that stuff. So the software that I'm using is Simon Brown's wonderful Sdr Console. I'll run a demo in a couple of minutes. Unfortunately, there isn't a Linux version of it, so I run it as a virtual machine on my main machine, which runs Linux. So basically what it does is it controls the whole system. So it takes into account frequency offsets for the receive and transmit paths. So basically the receive and transmit both track to the downlink frequency that you're looking at. You can also use because the beacons are really highly accurate, you can also use the beacons and lock onto a beacon and use that as a local source of timing to synchronize the whole system, primarily for receive, because obviously if you don't lock the LNB, you do get a certain amount of frequency drift, and the beacons just basically help to make sure that everything on the receive path is accurate. It also controls audio mute on transmit via the CAT, computer-aided transceivers. So basically it sends commands to the radio to say, shut up, switch off the audio, whatever. And it also supports the external controllers, such as the ELAD that I use to tune the radio. There's also a lot of other different SDR transceivers that are on the market that you can use to use with the software, and it's very, very popular. So my approach was that I wasn't too sure whether or not I could see the satellite from my back garden. So I didn't really want to put a lot of money into it. And I thought I'd just see whether or not I could actually get a signal from the bird. So I started off with the actual dish itself. I bought a cheap LNB. I think it came with it, actually. I was using the RSPDX for something else. So I thought I'd take that into the garden, power it all up, and see whether I could actually find it. So I got to a point where I could actually start to receive the signal. So this is the first test that I did. So as you can see, very cheap LNB, bit of standard satellite coax to the bias T, and then the bias T connecting to the RSPDX, and then just using a cheapo battery for the to supply power to the LNB. And that got me a signal. So then I thought, well, okay, reciprocity. If I can hear the thing, then there's a good chance I can actually get into it. So I did a bit of research on the feeds, and I kind of liked the idea of the helical. There were some other things that I was looking at. A very popular feed is the patch antenna. It's called the, oh God, I can't remember what it's called off the top of my head. The potty patch of the feed. That's another potential way that you can go down, but I did actually build this for a portable station that I've got, and I didn't have a lot of success with it, so I kind of ditched it. One of my concerns is, let me just change the cut. So one of my big concerns is the match between the 22mm pipe and the end of the LNB itself, because you basically chop off the feed point and the collimator, and then you just basically put the end of the potty directly into the LNB. And I was just a little bit concerned about losses in that. So I kind of decided, well, I'm going to go a different route, and I'm just going to stay with using a helical. Also, from what I understand, the potty is great for a center fed dish, but if you're using an offset dish, then you'd probably be better to use a helical feed. I don't understand all the physics behind it, but that, from an illumination perspective, that was what I was led to believe. As I say, your mileage may vary on that one. So I'm going to jump off the slide presentation for now. In fact, it'll give me an opportunity to kill the sort of various annotations that I've got. So I'm going to stop that and just give me 2 seconds. I'm going to stop sharing. Actually, no, I'll continue to share. So I'll show you what I do regarding how I get onto the satellite. So what I'm now doing is running the virtual machine up. And then because I'm running a virtual machine, I need to pass through the various different devices. So that's passing through the SDR receiver. That's passing through the controller for the frequency, etc. And then I'm going to pass through the audio and the cat from the transceiver. So if I now launch Sdr Console, and then run, right. So you can actually hear. So, oops, let me just tune that then. So this is the beacon that I mentioned, and it is absolutely so useful to use to tune. So effectively, you can use this when you're looking for the satellite. All you need to do is take the so the beacon's on 10.489.5 megahertz. Sorry, 10 gigahertz, 489.5. Typically, the local oscillator's 975 megs. And so that will give you an RX IF of 739.5 megs. So
Richard,
once you've got that, then you can fairly easily get yourself tuned up and start listening on that frequency for the beacon, and then you can start moving your dish to a point where you can actually receive it.
Can't see anything.
So I've got a sked, hopefully, with David.
Richard, can you hear a question?
So we can't see anything, Rich.
You stopped screen sharing, Richard, some time ago.
Oh, bollocks.
But it's absolutely fine. We're enjoying listening.
Hang on a
Enjoyed
second.
hearing the real radio and the Morse code.
Sorry, just give me a second. I thought I was still sharing. Share screen. Share. Right, can you see it now?
Yes, yes.
Okay, so this is Sdr Console.
Don't know about hearing it, though.
Okay. Got it?
Yes, thank you.
Okay, so that's the beacon. So as I say, if you can work out the offset, typically it'll be 739.5 megahertz using a standard off-the-shelf LNB. You can use this to make sure that you've got you can use this to align your dish, basically. And then effectively, so this is the PSK beacon. And then you've basically got your different mode, different sections of the band. And this is, so you've got the lower beacon, the center beacon, and then you've got the upper beacon, which basically says, don't go any further than this. You can also, as I say, use one of the beacons to lock your system. So for example, most people tend to use the center beacon and lock onto that, and then if, for example, your LNB does move, then it'll basically take into account the offset from the LNB, and it'll track it with the transmit side. So I've had a chat with David G4RQI earlier on, and we said that we'd try and set up a sked. So let me see whether or not I can. 770. Okay. Let me just come down from him a little bit. We did actually agree to be on that frequency, but let me see if I can find something a little bit clearer. Is this frequency news, please? Is this frequency news? Mike 0 Sierra November Romeo. Hello, David. Hello, David. Thank you very much for coming back to the call. Mike 0 Sierra November Romeo. Yeah, the demonstration I think is going quite well. I did mess up a little bit regarding showing my screen, but yeah, thanks very much for coming back to the call. You're 5 and 7, M0SNR, over. Yeah, sorry, go again, David. M0SNR.
Okay, Richard, yes, DTH, town of Castleford in West Yorkshire. The location where everyone seems to get on the satellite is the Oscar 93 Sdr Romeo. So back here, M0SNR
G4RQI, M0SNR. Okay, yeah, fine business. I had a bit of a problem with my LNB for some reason, so I just had to reset it, and the signal strength has come back up again. So yeah, 5 and 9 at the moment. So yeah, India Oscar 92 Charlie Mike, India Oscar 92 Charlie Mike. Your audio is fantastic, David. Back to you, M0SNR.
M0SNR from G4RQI. Okay, well, it's an HS rig. Driving a series of transmitters. I'm not here about 5 to 10 watts. On the antenna on transmitter to the 67 speed by Bluetooth dish with a circular patch feed. And then on receive, it's just an optic LSD 80cm dish. And that comes back to an SDR Play DX like you demonstrated earlier. And it's all got to GPS.
M0SNR. Okay. All right. Well, thanks very much, David. I think I've got a little bit more to go through on the presentation. And then I'll take some questions and answers, but thanks again for your support. Really appreciate it. So I'll talk to you a bit later on. G4RQI, M0SNR. Thanks again, and all the best, 7-3. M0SNR clear.
Yeah, okay, Richard, order. Okay, bye.
Right, I'll just close this down.
What's quite fantastic is the audio quality normally like that.
Absolutely, absolutely, absolutely. Yeah, yeah. Right, presentation. Let me just bring up the rest of it. So... Can you see this?
Yes, we can.
Okay, brilliant. I don't want to make the same mistake again.
That's fine.
So this is the portable station that I've also put together. So this is again from DX Patrol. The nice thing about this one is that it has also got GPS built into it. The LNB that comes with it is GPS locked. And if you have a look closely at the garden picture, you can see that I was faffing about to start off with a patch feed. And I've actually changed. So I've gone from that to using a different, basically a helical antenna again. I haven't really tried this in anger yet. It's been, the weather's not been too good, and I've been busy with other sort of bits and pieces, but it does work. The only problem that I do need, the Vox hang seems to be a little bit on the tight side. So that does need opening up a bit. So I need to slightly modify it and change the time constant of the, hang on a second. I do need to change the time constant of the Vox timing, so that's something I need to do. When it starts to get a little bit nicer, then that's something I'll probably do. But future projects, I'm not really that interested in doing DATV. One of the things that really concerns me is the amount of effective radiated power that you get from these things, and you kind of put in 50 watts into the dish at the feed, and given the sort of the gain of a dish, it gets into the realms of very scary amounts of EIRP, and obviously with the ICN IRP concerns that we've got at the moment, you just need to be. It's something I don't really want to go down the route of, and I haven't got the kit. It's not really something that I'm personally that interested in doing, but obviously your mileage may vary. People get some really good results, and from what I understand, given different types of compression algorithms, you can probably get away with doing HD transmission through the bird with less power, but it's something I might look at in the future. But the Adam Pluto from Analog Devices is a really interesting platform. It covers a massive range of frequencies. They're not that expensive. They're about 280 quid. I think they put out about 1.5 milliwatts on transmit. So you can easily use that as a sort of a prime mover for something to do a little bit more with. There's lots and lots and lots of videos on YouTube which talk about the Adam Pluto and using it. But one of the big problems with that, I keep on going about GPSDO, but a lot of people that have these and use them on air do tend to rip off or take off the included crystal and tend to use an external source for GPSDO. And again, they sound beautiful on air, and they're 100% supported by Sdr Console. I've actually been playing with one on 2 meters a while ago, but I've not done anything at any higher frequencies. It's a really good I would recommend anybody that's interested in SDR certainly have a look at it. I think it's a great platform. So with that, any questions? I'd like to open it to the floor.
Absolutely fantastic. Can I go first with a really simple one?
Yeah, go for it.
I live in the bottom of a valley, so what direction should I be looking to see if I've got enough height to see the bird?
That's a really, really good question, because 10 to 1, you'll be able to see it. If you can see, for example, if you can see any of the TVRO satellites, then you should be able to see it. So if you can see, for example, Astra, you've got a really good chance of seeing it.
Fantastic, right? Absolutely inspiring.
I'm sorry, it also depends on what you've got in the way. I mean, what I would do, if you download one of, you can get, there's a number of different apps that you can get for a mobile phone, and it uses GPS, and it'll basically give you a line of sight to whichever satellite you're looking for, and you can get them free of charge. So that will give you a really good idea as to whether or not you can see the bird itself.
Fantastic. If it's not snowing when we finish, that's where I'm going. I heard Phil then. Phil, have you got a question?
No, I was just going to say I might be able to help a little bit with Ian's question. I've done satellite TV work for the last 30 years. Sky satellite is at 28.2 degrees east. This satellite is at 25.9, I think you said. I've aligned dishes on this satellite to get Arabic channels many a time. So Ian, if you, I don't think you have satellite yourself, but if you look around and see anybody's Sky satellite dish and the direction that it's pointing in, then from that direction, it's only a smidge to the west and a tiny bit higher up. So that is the sort of direction that you're looking in. It's Sky satellite is 26 degrees in the sky relative to horizontal, so this is a tiny little bit higher. So that is the sort of way that you try to find out where you're looking. Look at, if you haven't got satellite Sky satellite yourself, look at somebody else's dish, and that is pretty well the direction.
That's fantastic, simple advice, Phil. Thank you very much. I will be doing that if there's any light, and I say as if the snow isn't there. Now, I'll look for hands, but by all means do jump in if somebody's got a question and I can't see, because there are two screens of you all. Looking along. Yeah, go for it, Roger.
Thanks, Richard. Really interesting. I've not played with that kind of satellite before. The Helix looks more like plumbing than anything I'm used to, but that's interesting.
the really beautiful thing about that was that I don't like faffing about with microwave stuff that much, and my view was that if I could just buy it as a 23-meter length with N-type females either end, then life's sweet. It's easy, and that's what I did. DX shop, and again, the nice thing is that they're naturally water resistant. I have wrapped the cable that comes out of that through the wall into the garden, but the one at the bottom of the garden is not wrapped at all, and that's held out through the winter, and there's been no problems with water ingress. The SWR on the system's been absolutely fantastic, no problems whatsoever. Yeah, if you want to avoid doing any weird and wonderful plumbing and sort of hacksaws and grenade guns and all the rest of it to build a cable, then I'd have a chat with the DX shop and just say, this is what I want, build it for me, please. And you'll get it in a couple of days. As I said, I've got no affiliation with them at all. But Roger has been an absolute really good guy to work with, really good. And again, with the CNT 600 cable, you can buy the correct N types for them, and they're a piece of cake to fit. Really easy, really easy. To be honest with you, I would say that N-type connectors are easier to fit than crap quality PL259s.
Yeah, the only ones I've played about with so I didn't make them up, but the guys they had little SMA connectors, tiny little, but that was just a link, very local, just linking one bit to another, a meter long.
Yeah. But again, there are
ring door use,
There are so many different. Some of them are really good for 10 gigahertz, and you pay an absolute fortune for them. But some of them just work to about 2 gigs or something like that. I'm a little bit skeptical about buying stuff from Amazon. Low frequency faffing about with 700 megahertz, that's not a problem. But if you start to talk about 2.4 gigs or anything like that, I'm kind of getting to a point where I'm kind of thinking, well, it's cheap stuff from China, and I don't know what the quality of the cables actually is.
The question I had really was, do you notice any degradation or effects of the weather with that frequency? We're just in the middle of a snowstorm right now here, so I just wondered.
I see a little bit of change. I've not seen. We live in the south. We're southern puffers down here, so we don't tend to see too much of a problem with snow, and I haven't had a massive amount of snow. I do see a little bit of degradation on receive occasionally, but it's not too bad. The signal to noise ratio, I'm getting about 70, normally about 80 to 78 dB, neg dB signal strength. So it's a fairly strong signal to me. And if I need to put the power up a little bit more to get into it, another nice thing is you can actually see your own signal strength coming back from the satellite. The weird thing is you get about half a second delay on transit between you and the bird and coming back. So you can get an idea as to what your signal going into the bird's like. If you put a decent sized dish up, that you shouldn't see too much of a problem. And if you really want, if you wanted to, depending on the receiver that you use, you could also get one of the a small LNA and put that between the RSP DX receiver or whatever it is that you're using. a 5-volt bias on that, and then put that on the RF side of the bias T, and then use that to give you a little bit of extra gain on receive. But to be honest, you shouldn't really need to do that with a what I mean. Your mileage may vary. I mean, again, you're a little bit further north. I haven't seen any. I mean, my big problems as far as satellite's concerned is trees. I don't see too much of a problem with snow, but I do have problems with trees.
Right.
And that's only on that at the moment is only on Sky. This dish is fine. It's right at the back of the house. It's seen right the way over the top of the trees, and it's not a problem.
Yeah,
and
so
I've not seen too many problems. Even if it absolutely hammers it down with rain, I don't see too much. I can still use the system perfectly.
That's interesting because you just have this amount, in your head that it's going to get absorbed so much. It's the microwave region; it's going to get absorbed. Fair enough. Thank you for that. Really interesting. Good signal to noise ratio. Thank you.
Cheers.
Anybody else with a burning question?
Me, Alan, GHLJY.
Hello, Alan.
Hi, Richard. I used to live where you are. I used to live in Bromsgrove, but I live in Somerset now.
Okay.
Just to say, I'm doing it slightly different to you in that I bought a transverter from, I think it's the Ukrainian transverter store before all this started, as you know. So I'm using my old FT726 up here.
Yeah.
It's got a knob on it marked satellite, which puts it in sort of split mode. So what I thought was, I'll put the transverter in line with the 2-meter receiver, and then the up converter, which is a board I bought from the guy in Portugal, and I bought a Wi-Fi amp from China.
Yep.
So that's going to go in a box the same size as the modules that fit in the back of the 726, because there's one free. So I can put it in there and have it all contained in one box. Is the plan?
Brilliant! Wow.
So
that's nice. You're gonna have to send me some pictures of that, definitely.
I will do when I get it working.
Please.
Of course, I haven't done anything with the weather being wet.
That I like that idea, but you're gonna have to do something with the cable to run down to the dish.
Yeah, well, I'm looking behind me. This is the smallest bedroom. Just beyond that wall there is a sky dish, just to the side. So the sky dish is that way, 28.2 east of south. And of course, the other one's only 2 degrees off it. So it'd be right outside this window, about 2 meters away from the dish.
Hang on a second. I can't see what you're. I can only see a few people. Hang on a second.
I'll wave.
I'm not very. This is the first time I've used. Hang on a second. Let me just put this down. Actually, tell you, just before I finish, there's one last thing that I wanted to show you, and then I'll come back. I'll come back to you, Ian.
I like your antennas, the woodpecker antennas on your home screen. I'd like to go and take a picture of them now. It'd be a bit dangerous, I think.
Apparent. I've got you. Is it Jeff?
Alan Griffiths, G8LJY.
Apparently, all of the whole thing has basically collapsed now. Well, it's not collapsed, but it's been decommissioned.
Yeah.
And there were a lot of people using it to base jump off.
Oh. I know somebody, a friend of mine, who went on a visit there before Ukraine kicked off, and you could pay somebody local as a guide to take you around the place.
That's right, yeah.
Yeah.
It would be fascinating to go.
Right.
But this is the last thing I wanted to quickly share. This is my... this is a network that I'm playing. This is time-sensitive networking. So I've got a Grandmaster clock, and then a couple of our evaluation boards for switches, which are all time-sensitive. And so I've got network jitter at the moment down to about 1 nanosecond between the two 19-inch devices running precision time protocol and synchronous Ethernet, and I'm hoping to get the rest. I'm hoping to get the same results from the other boards as well. But I just wanted to do that before I closed it down. But yeah, very, very interested to find out a little bit more about what you're doing.
Okay, I'll sort something out picture-wise when I've done it, and I'll be in touch with you. I'm in the you're in the QRZ book. I just checked you out on the phone, and it's got. I assume you're in Great Bar by the look of the address. Is that right?
No, I'm in Castle Bromwich.
Oh, in Castle Bromwich, right? Okay. Yeah, I used to live in Catskill in Bromsgrove,
okay.
Which before I moved down to Somerset 20 years ago. Yeah. Yep. So I'll be in touch. Send you there's an email on it.
Brilliant.
Buzz Ed.
Yeah. I mean, if you want a QSO partner to have a play with to try the system out, absolutely give me a shout. I'd be more than happy to be there on the other end of the line for you.
Cheers, Richard. It was useful what you said about the type of antenna for the uplink, because I bought one of those potty things from the guy in Paris, which I haven't assembled yet. And after what you've said, I think I'll probably look around for the other type. Actually, I wondered if there was an issue with focusing it on the dish, because it's a lot easier with a prime focus dish, isn't it, than it is with an offset.
Yeah. Have a look at DC8 Papa Alpha Tango.
Yeah.
Or Delta Oscar 8 Papa Alpha Tango. He's got a couple of different call signs, and he's done the actual design for it.
Okay, is that where you can buy it from? Is it, or you buy the cone from somewhere else, or is that an improvisation?
I bought it directly from him.
Okay, that's Delta Oscar 8 Oscar Papa Tango. Is that correct?
No, PAT Papa Alpha Tango.
Oh, Papa Alpha Tango. Okay.
Yeah. You could also have a chat with DX Patrol, because they've got one. It's not a 3.5 turn. It's a little shorter than that. But again,
all right. I'll check that out. I like your uplink, but I don't think I could afford that unless I go and rob a bank first. So the Coon ones are really nicely made, aren't they? But there we are. Anyway, I'm taking over the net, and I shouldn't be doing this.
Welcome.
It's nice to speak to you, Richard, and I will keep in touch when I get it assembled.
Yeah, please do. Definitely. Drop me an email.
We'll do, Richard. I'll pass it back to the Chief Controller, as they say.
God bless you.
I'll switch. Hang on a sec. All right.
I'm never the controller. We'll best leave Richard in charge. Has anybody else got a burning question whilst I look through everybody else, through your pictures to see if anybody's waving? Because if not, we'll leave it for Richard to give us the last word before we thank him in the usual inimitable fashion.
G3VFC.
Oh, go for it, Terry.
Yeah. Thanks, Richard. Very good. We've got one of our club members, Jen G4RQI, who is on QO-100, both narrow band and wide band.
Okay.
And she bought the kit down to the local club a few months ago now, and as a demonstration, parked it outside, and we failed to get a contact. And subsequent checking indicates that it's trees that were the problem. Worked perfectly back in the usual QTH.
I think.
So, yeah, trees do hinder.
I think the thing. I mean, as long as you can. I mean, the way that I tend to set my system up when I'm portable or going out is that I'll look for the beacon first. If I can see the beacon, then I mean, with the DX Patrol system, I know for a fact that it is locked on both transmit and receive. So if I can see something coming back, if I can see the beacon, I know I've got the dish aligned, and then if I QSY to part of the SSB section of the band, put a shout out, I should be able to see myself coming back on Sdr Console. And if I can't, then I know I've got a problem. So, sighting, obviously, with the microwave system, yeah, sighting does really come into it. But I mean, what I found, for example, the sky dish is at the front of the house, and it can't see anything now with the trees. I had it moved back about 15 feet, and it can now see the satellite. And then the main dish itself is probably about another 15 feet towards 20 feet towards the back of the garden, and that can see the QO-100 satellite. So if you can move yourself away from the trees, then you tend to give yourself a better chance of getting over the top of them.
I'll just mention that trees are a satellite installer's nightmare.
Yeah.
You might get a signal through them at this time of year, but if a tree's in leaf, you will get absolutely nothing.
Yeah.
Sky. So I used to use a triangular set square with a line marked on it at 26 degrees and hold it perfectly horizontal. I could then tell whether I was getting the signal over the top of the tree or not. Many a time I've had to put dishes on, stuck upon poles and on chimneys to get the signal over trees. As I say, they are a satellite engineer's nightmare.
I know.
Well, thank you, Richard, for actually getting us a QSO on air, and it being real and there being somebody on the frequency already just made it all that much more real.
And to be honest with you, a lot of thanks goes out to David G4RQI, because I did actually have a chat with him beforehand, and we've actually had quite a couple of really interesting chats. But thanks very much to David for supporting me on this one.
Fantastic. Well, I think we should all show our thanks and our best wishes, and thank you very much for showing us in the usual way. Really appreciate it.
Thank you very much. I'm glad you enjoyed it. I hope it was worthwhile.
Absolutely.
Well done. Thank you.
Before I pushed up on the recording, I'll just let you all know that 13th of April, the next meeting is with Wayne, Kilo November 2 Zulu, who's joining us to give us a demonstration on JS8. So,
oh, wow.
We'll see you there, Richard, in that case.
Absolutely.
Fantastic. Thank you very much.